There are two ways we can solve this equation. One is in a semi-infinite or an infinite domain, which would be using things like singularity solutions and so on. You would end up with a series of usually error functions and so on. The other way is if this is a finite region. I'm claiming this to be a finite region, and we will solve it for a finite region, which means we will use separation of variables, which is very straightforward. In order to have separation of variables, we will take this, very simply we say that psi is equal to some function t, which is in time only, times some function x, which is in x only, times some function capital Y, which is in y only, times some function capital Z, which is in z only. We multiply all of these together. We substitute back, and just to make it easy, we'll go I h bar t prime x y z equals minus h bar squared over twice m t x double prime y z plus t x y double prime z plus t x y z double prime doom plus v times t x y z. Managed to get it all into the board. And then what we see in order to separate the variables, obviously we want to just divide by t x y z, which would separate the variables. However, we can't divide by 0, so we make the statement. And if we're able to validate this according to the Wronskian, and we're able to fulfill the Wronskian, then our assumption would be correct, which would be that psi cannot possibly equal 0, or that t, x, y, z, these four functions multiplied together, cannot equal 0. Okay, so we now divide by t, x, y, z, divide by t, x, y, z, divide by t, x, y, then, etc. That cancels, this cancels, the z's are left over here, y's are left over here, x is left here, this cancels, this cancels. We now have it separated, so we have I h bar t prime over t equals minus h bar squared over twice m. The variables are separated nicely. X double prime over x, y double prime over y, z double prime over z, plus a constant v, which means, of course, it separates out because the linear function will end up with the constant at the end. So now we can set forward the eigenvalues for each of these terms and then be able to move to a general solution of Schrödinger's equation.